how can we summarize the characteristics of this star schema? The dimension tables are not normalized. Maybe I should change this line, because indeed there are consistency problem, but should be solved by the ETL. So suppose that the category information changed somewhere. So it is on the next refresh of the data warehouse that new values for this category have changed something here. But then it is the responsibility of your data refresh, your ETL process, to ensure this consistency problem. So, but at this level, we say we need to somehow separate concerns. At this level, we suppose that the database is consistency. You delegate the consistency problem to the team that is managing the ETL process. The reason is that we avoid the need for joins and we use surrogate keys. Does anyone knows what does surrogate key means? Surrogate keys are numeric values in which you can say customer 1, customer 2, customer 3, independently of the, I don't know, the number of the customer, or so the number of the customer is typically 1. But you know, you need to identify not a category beverage, for example, but you put a database generated identifier for every information in here. Why is it important to have surrogate keys? That I mean, arbitrary identifier generated by the database.
Because sometimes, like for example, the key of the table that it comes from, it's probably like a big key. So doing joins with that, it's expensive. So I mean, you just needed to do the join. So you use a separate key.
So the idea is indeed, suppose the date, as you mentioned, the date, as we discussed last time, the dates are typically encoded by microseconds or milliseconds after some reference date. That will be huge values. And do we need to put in our data warehouse 2000 years before and 2000 years after? No. Therefore, we put a single counter, 1, 2, 3, 4, 5. This is a serial key generated by the database for every possible date value. And then you will have how many? 10,000 for 10 years. So it's not a big deal to have 10,000 numbers as generated by the system. So this is important also, not only for efficiency. Andres was talking efficiency, but also because the real identifiers change. In the case of ULB, the course number changes so many times. The student identifier changes so many times. Because when, I don't know, it was in COBOL, in the 1960s, it was written in COBOL, and they have one identifier for the student. But when this identifier entered the SAP system, of course, they modify the thing to manage things better. So the key, this is important to understand the real keys. Even your customer number in Amazon could change. Therefore, you can see your customer number, but internally probably they have another customer number which is generated by the system. So this is the idea of surrogate keys. Let's see this example. So for example here, these are the surrogate keys. Customer ID. The problem is this, look at this. Suppose that you have at some point in time two customers. One, suppose that they are life partners. They live in Dallas and later on they live in another address. Of course, by managing this, you have, or even your name can change. Nowadays, you can, previously in Belgium in particular, for example, you must have the name of your father, male father. Nowadays, you can choose whether you keep officially your mother name or your father name. And then suddenly someone became a new family name. And therefore all this can be solved with the surrogate key. Look at things like this. For the values also, of course, will change. Even some categories disappear. So this is all the things that we need to change. We need to take up the evolution of all these dimensions, but somehow you alleviate the problem by having this surrogate key. And we will see in the next chapter, this is called typically slowly changing dimensions, is the temporal aspects. But as I already told you, the solutions provided by SQL Server and the others are not as good as a traditional temporal database solution that we are seeing in the other course. So yes, the problem is of course of aggregation. What is the problem? Suppose that you have a first version of the dimension in 2000 and a second version of the dimension in 2010, and of course you need to aggregate sales by address of customer. How do you do that? You get the problem that 10 years ago, the value of these two sales have been aggregated to the previous value, what was Dallas. Nowadays, we updated this dimension customer, and therefore the address is the new one. How do we manage the aggregation of the sales 10 years ago? Should these values go to New York or to Dallas? What is the business perspective of this? Not the technical perspective. How should we aggregate?
10 years ago.
Sorry?
10 years ago.
But this 10 years ago, the information is no longer there. You get the idea? Nicole, you wanted to say something?
If it was bought 10 years ago, I believe it should be from Dallas and not New York.
So that is what we should more precisely characterize the distribution of sales by address. But if you are doing a simple data, non-temporal data warehouse, you lose this information. You get the idea? So this is why do we need to, basically the idea is we are saying we need to aggregate this is one possible scenario, aggregate the facts to the values of dimensions at the time the sales was generated, and not the value of today. But we can also compare the things. Suppose that you compare the same sales with the value at the time when the sales was generated and the value today, do some analysis and do some interesting marketing strategy. Okay? So, but these both are valid requests. Depends what do you want. So one possibility is indeed to have surrogate keys. This is why they call the traditional client number. The client is the same. The client is the same, but we have a surrogate key here. And then we put the surrogate key at the time of John S1 here. This will be, of course, aggregated to Dallas. And this would be the new ones, S5 and S6 should be aggregated to the new value. So we are already taking care of some aspects of temporality here by simply having the right surrogate key. Of course, look at this, the temporal aspects are here, because we can have, we don't keep the timing information. I mean, apart from the link here to the primary key, here, but we don't get when this customer changed from Dallas to New York. But at least we have already the right aggregation if this is what we want. Nicole?
So every time you do an update, you actually do an insert with a new surrogate key?
So this is a possible trick to say, I don't want to be more precise. I don't want to have a full temporal table there. I do not have periods there. Okay, but nevertheless, the association between, so you have multiple versions of every single client record. And with this simple trick, you can already solve some evolution of dimension data.
This sounds very expensive.
That sounds very expensive indeed, and all possible temporal solutions, as we are seeing in the other course this afternoon, and even here, it's always expensive. But this is what the business wants. To have a correct aggregation at the time towards the address at the time of the sale, and not at the time today. So this is what I mentioned. That data typically in operational database we overwrite, and we would like to avoid this in data warehouse. Second variation, snowflake schema. So in this case, we are solving another problem, is the normalization problem, avoiding redundancy. Pietro was very careful about pointing out the problems we have with redundancy in data. Now we have solved this redundancy. Of course, when you have a product here, you have a category not even named, but a surrogate key that points to the right table for the category. So if you have 100 products here and pointing to the same category, you update only once here, and by the referential integrity, you have already the updates to all the 100 products. So again, this is, but imagine doing that for every possible dimension, even for dates, of course. The date has a single month, the month has a single year, etc. So in reality, depending on what do you want, you have a mix between a star schema and a snowflake schema. And for each dimension you need to decide. For example, in our book, we use spatial data warehouses, in which, for example, we have a geography dimension here, and then we have the geometry of every city, of every region, of every province in the database. This is information that I would like to avoid to repeat the geographical information, because it is very costly, it takes a lot of space. So I do not want to repeat the geometry of Brussels at all the multiple points of my geometry of Brussels to every customer of Brussels. So this one is a candidate immediately to put in a snowflake dimension, because this information, geographic information, takes a lot of space. Dates typically are never the date dimension is typically never put it on a snowflake style. We're avoiding redundancy, because date is so important into all the queries that you need to have less join for the date table. And in addition, you remember you can have a sales date, delivery date, complaint date, many date dimensions associated to the same fact. So this is what I say, more normalized normalized dimensions, avoid redundancies, reduce the size. This is the example I mentioned about the geographical dimension, more efficient data insertion, you pay in joins. Again, what will be my methodology, but it's an intuitive methodology. I put my data warehouse in a star schema. If I'm beginning to have problems in the ETL, maybe I can normalize one or the two problematic dimensions and little by little to tune up according to the requirements for my application. And then a constellation is basically the fact that you can, basically the situation that you can have multiple fact tables. So suppose that you have at the same time sales fact, but you want to also manage your logistics. Warehouses, where is located your products, etc. So you have several facts. Some facts share the same dimension. Supplier, customer, date. These are typical dimensions shared by multiple facts. Typical example, even in the Adventure Data Warehouse example given with Microsoft Server, SQL Server, you have sales by internet sales and shop sales. Of course, you imagine that internet sales do not need a sales representative, but online shop sales will have additional dimension. Of course, the same customer can go through internet to buy something and go to the shop to buy something else. The same customer are shared and the time shared by the two dimensions. You get the idea of constellation. You have many data fact tables sharing some of these dimensions. Yes, of course. The problem is this is a typical keyword in the data warehouse domain, conform dimensions. The ULB is very simple. We have, logically it's a single database, but there are several databases, one for students, one for personal, one for finance. All of these are more or less connected together. But what is the problem? The vision of the student, the attributes of the student for the education department are completely different for the financial department. Why? Because depending on many complex characteristics, you get or not subsidies from the government, whether you fail your course, whether your parents are from which nationality, how long you will live in Belgium. So you have different characteristics for the same real world object, which is a student. And then, of course, when you build your data, you remember that we said that we have an incremental way to construct a data warehouse. So you start with the student data warehouse to see how much, how well the performance of students, how do we increase the success rate for students. Okay, so we have implemented. Suppose that this is here some student. You have implemented the education department view of the student. Then when you want to extend this data warehouse to the financial department, there are things that are not necessarily compatible. The two databases are not necessarily consistent. You have to add additional parameters in your student table. So the idea is that this is the idea of conformed dimension. The definition of what is a customer, what is a date, what is a product should be agreed by all the departments. And this is not evident for large organizations. ULB is a very small organization, 5,000 employees. But this is much harder in large organizations. Imagine the notion of a product or the notion of delivery for a large worldwide company like Amazon or DHL. The same delivery is managed very differently in Costa Rica or in Brussels. And then you need to put a single data warehouse with all this information. You need to get the two managers to agree on a common definition on what do we put in the data warehouse. You get the idea of conforming dimension. It's typically the case when you have multiple divisions inside an organization. Yes.
So does this come back to when you're talking about top-down versus bottom-up database design? If you're doing top-down, it'd be very easy to ensure conformed dimensions because you're deciding up front what it's going to be. And if you're doing bottom-up, then do you end up with like a dimension table, or sorry, a fact table that correlates the unconformed dimensions?
No, the idea is that indeed you discuss this schema with either of these or this. You discuss this schema, and then the education department manager is happy with this. And suddenly the finance department manager say, no, this is not what I want. My definition is different. Even my student number will be different because there will be a student number for ULB, and then probably there will be a student number for the ministry, which I will use as primary key. So these kind of problems arise. Of course, if you are doing a top-down, up front, you already try to put all the managers of the university together and spend 1 month deciding what is a student. Maybe you cannot afford that. So you start with one and then try to little by little add additional requirements from the other managers.
So if you don't have, I guess my question was, when you don't have conforming dimensions, do you just end up having more definitions on the back end, like hidden from the users for our database to be able to relate everything?
Yes, basically you need to here modify things in the dimension that little by little matches the requirements of all the different visions of the same product, of the same department, of the same student across all departments. And the problem, of course, is the conformed dimensions. I mean, managers sometimes have a huge ego. And of course, each manager is more important than the other managers. And then you need to put the two managers that have been fighting for 20 years together, sit on a table and decide what is a student or what is a project. This is a complex issue. So if only for human reasons, the top-down approach has been more useful. Yes, so for example, we have seen this. Sales with these units, with these measures, quantity, unit price, and VAT rate. And then here we have 3 dimensions: product, date, and customer. Each of those has hierarchies. This hierarchy, traditional calendar hierarchy, day of week hierarchy, customer, etc. So how would you represent this in a relational schema? One possibility would be simply like this. Of course, how many dimensions we had there? 1, 2, 3. So we need at least 3 referential integrity keys that point these sales, relate this customer, this date, and this product, and then you repeat the information that you have in the measure you have in here. Yes, one question.
Yeah, I think it's the same question, but just to be sure I understood correctly. Is the first one is like the conceptual schema, and the second one is the way you can implement it in a certain technology.
So basically, this is what your manager sees, and this is what you see in order to write queries, SQL queries on top of that. But of course, for the manager, that is enough. So, I mean, whether this model or any other model, conceptual model, we are modeling information, and the information is agnostic of technology, and this technology changes. Until 20 years ago, relational was the only one. Now we have. Now we need to add a new course, advanced database, to see all these variations of technology, and you can assess. But the same conceptual schema you can implement it in whatever technology, because we are modeling information, nothing about technology here. Okay, with this idea.
And sorry, just to build on that one, to be sure, this is a conceptual schema, and what we went over a couple days ago with the different ways that you can show like temporal databases and things, is that just a different way of representing a conceptual schema?
I mean, it depends on, there are many conceptual schemas depending on what aspects you will need to mention. The basic understanding is conceptual is we are modeling information, we are modeling the real world. Logical, we are already committing to a particular technology, relational, key value, columnar, in memory, so it's already one technology. But this is the logical level, not again physical, because among MongoDB and CouchDB, there are variations that you need to take care of the final physical schema that is implemented. But more or less, all key value stores will have a similar schema. There are some, of course, but more or less they are common in these characteristics. So this is the traditional idea. Conceptual is technology agnostic.
Yeah.
And in the case of the conceptual model, we have seen the temporal database. It's a traditional UML or entity relationship in which we need to highlight the spatial characteristics. So we will see the temporal characteristic of the spatial characteristic or some other characteristic. We will see also for the ETL, we can define ETL conceptual models. That is again, they explain, they take this file, I extract this information from this file, and then I combine with information if there are mismatch. So all this is manipulation of information independent of how we do it. So going back to this translation, we have here, the first thing is which will be the schema of the fact table. So as I mentioned, 1, 2, 3 dimensions, we put the three keys here. And of course, this is why we say it is dimensional. You understand by the underlining that this is the combination of the three, which is the primary key of this table. You get the idea, because for the same customer, for the same date, and for the same product, you decide that there will be one single record with these three values. What we said here, if we are thinking of our supermarket sale that we all do often, is that if I go twice to the same supermarket, different dates of the different hours of a day, I don't get, I decided in my database, data warehouse design, I don't want to care about this difference. I aggregate, in the morning I bought 2 bottles of Coke, in the afternoon I bought 1 more, and then they will be aggregated into 3 units here. Because this is the granularity at which I am recording facts into the data warehouse. Suppose, exercise, I want to differentiate a sales in the morning and a sales in the afternoon for the same customer, for the same day, and for my product key. So in essence, I need to increase the granularity of this data warehouse. What should I do? At time, we need to have in addition, do we have date and then we have hour here or not?
Hour is like lower granularity, so it will be we will add above date.
You can aggregate it so it's not hour, but morning or afternoon or evening.
Or suppose that the hour is important. I need to have at this level of granularity, yes?
I think you would do that in a separate table, like time. And I mean, you could list it there and then have like a column to identify the criteria. This time is like noon or something like that.
This is a very interesting discussion. If there is some slide after in the course, but maybe we can already have it a small discussion here. So my question that some of you already understood very well. So we have two possibilities. This is the fact table. And then we could have date or the date hour. Let's put it date hour here and point to a single table which is called date hour, and then we have hour. I mean the timestamp, date, month, etc. Andres is proposing an alternative. And not only Andres, also you, remember your name?
Ismail, but I know I was suggesting to put the time in the date.
Date and time, so it will be an alternative solution, date here, time here, and let's put it date time. And let's put it date time so it is very clear. So we have a time, dimensions, and then what will be. Let's see already before putting attributes, what are the difference, advantages and disadvantages. I'm not saying that one is good or bad, yes?
I would put it separately because if you include it in the date table, let's say you have a granularity of hour. So every Monday, for example, Tuesday, every day that you have to have 24 registers per each.
But hour is not enough. Typically, if we want at this level, we go to granularity minutes and seconds.
Yeah,
We have a timestamp attribute in our database.
Yeah, I'm oversimplifying it there, but if you have more granularity, it would be worse. You have a lot of registers in the date table. So I would just like put that in a separate catalog. Let's assume we are just talking about hours. So you would just have 24 registers in that table, and then you can have a separate column in that same table that categorizes, okay, let's say from 0000 to 6, it's this category, then you have for the other, you have another bucket, another category, and then you can just put another key in the fact table.
So now that you understand the alternatives, who will prefer this one or the first one?
I think before you do that though, the question still exists of how often are you actually querying and pulling the data? Because what Andres said earlier, I'm surprised that you're so all for option 2, because the question is how often are you querying, because the join is an expensive operation. And so if you're having to join like multiple times a second or multiple times a minute, then would it not be better to have it in a single table?
I guess my reasoning for that as well would be, remember also that this data most likely won't be static. So in the future you probably want to update, and let's say for some reason you want to change like the cutoffs, because I don't know, management said no, we want to include, our process is delayed 1 hour, let's say for example, so we need to change the category now we need to include 1 p.m. as well into this bucket. If you do it in the first alternative, you have to update a lot of registers. If you do it the second way, you just have to update one of the tables, the one that contains it.
The idea, the criteria would be how often do we use this time, aggregation by time and aggregation by date. Depends on which kind of domain you are. If you are doing, I don't know, stock exchange data, then this time information is very essential. because in a few minutes the situation could be completely different. If you are Amazon, even for Amazon, you want to aggregate mostly by day, not really by time, or maybe you have a little bit, put more machines to have the customer wait less from, I don't know, from 12 to 11, because this is the time, the break when the people are buying things. But even that, the idea is how much you have an aggregate by date and how much you have an aggregate by time. My guess is that 80% of aggregation shown to the manager will be by day, not by hour. And then, of course, if I have to aggregate all the seconds that are inside a date, I need to aggregate many, whether it's already aggregated in the second schema. So it's really how in stock exchange data probably you will have something like this. In more traditional, you will have a double dimension.
So I think data marts we talk more about in advanced database, but maybe if you have multiple business units that look at the data differently. So to your example for Amazon, maybe they're just looking at historical sales in the last month, but if I'm on the marketing team, I want to be looking at my time of day. So
good point.
How do you end up handling that with by having both? Can you have both fact tables and just depends on who it is, or do you end up having data marts that have duplicates of information depending on which business unit is accessing it, or how do you actually deal with that?
In your very nice example, suppose that again it's 20% rule. Suppose that 80% of the units their business case is in date. Maybe you can favor that and penalize a little bit. It's one single join for not hundreds of additional joins. It's one single join in addition. So you have here a time key and a date key that points to the corresponding record here. You have one additional joins among, so that will slow down a little bit for 20% of the cases. But having two, it's maybe too expensive, because then you will penalize the ETL process, because they need to push the same information in two different tables, and that is also expensive.
So either everyone will get penalized a little bit, or one department will be penalized more than the other.
Mm-hmm.
But someone's going to have to take a penalty.
I mean, the usual example I say, I always use at ULB. What is more important? The rector is the big boss of this organization, but at the same time there are students encoding, especially during the registration peak in June, July, August. They are, an army of students helping their the registration and getting money, pocket money for that. And then I have a query that I need to optimize. Do I prioritize the students that are doing the encoding, or should I prioritize the rector? What should I prioritize my queries? I cannot have the performance increased for both. Who should I prioritize? The students, encoding students, or the rector?
Students.
Of course. But I cannot say that to the rector, because the rector will say, how come my queries are so slow? And then you say, yes, but the director has ask a query and then goes in the airport for whatever. The student has to work 8 hours per day. And this is the one that the more registration at ULB, the more subsidies we have. So this is important. The rector, of course, is important, but making the director wait 5 seconds is better than with the hundreds of students encoding that need to wait 5 seconds each of those. Okay, so databases you can have, you need to do multiple compromises always. You cannot have a single structure that makes everybody happy. Unless then you need to change your server and do this on the cloud, and even that does not solve the full problem. Depends on the size of the data you manipulate. So now let's continue with this example. How do we manage the dimension data? So here we are saying we are coping with star schema. Then we do not care for star schema. We need to put all this information in a single table. Even if there are redundancy, product, brand, type, customer, city, country, all the attributes are just there. Look at this, I defined also already here that I have a surrogate key in the database, which is different from the OLTP customer key in the operational database. This is a traditional solution. And then you add all the attributes of each dimension. Another interesting question. Yes, Nicole, you have another one before?
What is the surrogate key in the custom table?
Is this one. So this is a data warehouse key. Let's put it in this way. This is the data warehouse key, and this is the OLTP key, the operational database key, my AFOH 415 or 419. But this operational key has changed many times in the past, so I preserve myself from this by having a single data warehouse key for always.
And does this drawing imply that for the sale table we have a surrogate key as well?
That's about what next question. Should we have a surrogate key for the sales table instead of all these? Of course, you will not have 3 but 50 keys. In the 50 foreign keys in the sales table. Should we have a surrogate key for the sale?
I would argue no, because all of your other keys are already surrogate, which I think.
I mean, the combination of all these.
Yeah, creates a surrogate key in sale because they roll into it.
Yes, is someone else with a different. Is there a business scenario that could be interesting to have a surrogate key? Supposing that there are 50 of these foreign keys.
I guess at that point, your primary key is very long, and if you're trying to search through it, then it's not very fast.
Indeed. So typically a traditional way is to have 2 keys. You have a surrogate key, which is a single integer, very easy to count, average, mean, max, etc. with this surrogate key. But at the same time, you need to ensure the database, this is an alternate key or secondary key in which every time you enter something, there should be, you generate a surrogate key, and then you ensure the database that the combination that you add also is unique. Okay for this? So I think, yes, additional, maybe we can continue that next, tomorrow. There are a little more details to cover all the other aspects of the dimensional model we have seen. So we cover this tomorrow, and I will also do some paper exercise in order to next week, you know that I have to catch up a couple of courses. So next week, even if it is officially recuperation, typically next week is holidays, except for the catch-up classes that I need to catch up. So I will need to catch up at least two classes. So there will be next week normal courses.
Monday and Tuesday as well?
Sorry?
We have Panic on Tuesdays.
You have?
We have Panic on
Yes,
Tuesday.
we have trips. A lot of students have trips on Wednesday.
Which is your trip?
Students go to
Okay, I was not aware of that. I will take care of that, and then so so when you are not there next week,
Monday.
and then after that, whatever you don't have any other problem for rescheduling the course we have missed because of one day I was sick and 2 days were holidays.
What does that mean? What's the process here? Sorry, I didn't realize that we schedule missed class time. How does that, what's the process?
Typically, we have 12 sessions of theoretical courses and lab sessions during the semester. Sometimes if it happens during a week or the time I was not feeling well, I need to reschedule in these buffer weeks.
Okay.
And then, so since you told me that, then I need to ask for lecture rooms Wednesday or Thursday or Friday. Okay.
And Saturday is not available.
No, I mean, there officially it is also is possible, but I would like to give you free for your weekends also.
Wednesday would be best because Thursday and Friday are pretty intense. If it's possible to do Wednesday,
Okay, I will try next Wednesday
I'll just put
then.
that out there.
Perfect.
Yeah.